Welcome back, class. Today we're graphing quadratic functions in factored form, which is y equals a times x minus b times x minus c. Let's go ahead and get into this. Example 1. Graph the function. Identify the vertex, axis of symmetry, maximum or minimum values, and the y-intercept. So we have this function which is y equals x minus 4 times x plus 2. When graphing functions in factored form, you're going to need two things. First, you're going to need the scale factor, which is a. And second, you're going to need your x-intercepts. So our a value is going to be in front of the first binomial. And because there's no number in front of our first binomial, let's go ahead and put a 1. So our a value is 1. This tells me two things. Because it's positive, I know that the graph is going to open up. And because it's 1, the graph is of regular size. So it's not wide nor narrow. In regards to the x-intercepts, I want to rewrite the function and then set each factor equal to 0. Right now, I'm just setting them equal to 0, x minus 4 equals 0, and x plus 2 equals 0. Once you have your equations set up, go ahead and solve for x. In the first equation, I want to add 4 to both sides. That's going to give me x equals 4, which means that my first x-intercept is at 4, 0. When x is 4, y equals 0. To find my second x-intercept, I want to go to my second equation and solve for x. So subtract 2 to both sides, x equals -2. And as a result, my second x-intercept is at -2, 0. Now that we have our x-intercepts, let's go ahead and plot them. We have a point at 4, 0. Remember, these are x-intercepts, therefore they should be on the x-axis. 4, 0 and -2, 0. Afterwards, we need to find the vertex. Okay, so let's look for the middle, and once we've identified the middle between the 2 points, then we can draw our axis of symmetry and our vertex. So the middle part of our graph is going to fall on x equals 1. And that's our axis of symmetry. Now we need the vertex. So I know that our vertex is going to fall on the axis of symmetry. The x-coordinate of my vertex is where the axis of symmetry is at, which is 1. To find the y-coordinate, we need to take our x value and plug that into our equation. So the equation is y equals x minus 4 times x plus 2. Let's take the 1 and replace all the x's with 1's. 1 minus 4 times 1 plus 2. 1 minus 4 is -3, and 1 plus 2 is 3. -3 times 3 is -9. So the y value of my vertex is at -9. So let me go back to my coordinates. When x is 1, y equals -9. Let's take our vertex and plot it along the axis of symmetry. we need to go to 1, -9. Remember our scale factor from earlier? Now our scale factor is going to come into play. I know that the scale factor is 1. To use that, we want to go back to our vertex. The vertex is at 1, -9. The scale factor is 1, so from the vertex, I want to go 1 unit to the right and 1 unit up. And because this is a parabola, I know that my points are going to be symmetrical. So if I have a point that's 1 unit away, on the right side, I'm also going to have a point that's also 1 unit away, but on the left side. Now that I have my points, let's go ahead and draw our graph. Label it y equals x minus 4 times x plus 2. So now let's just make sure that we covered everything. We've identified the vertex. We've labeled our axis of symmetry. The maximum or minimum values. Our vertex is the lowest point, so that's going to be a minimum. And the minimum y value is at -9. And in regards to our y-intercept, that's going to be where the graph crosses the y-axis. And the graph crosses the y-axis at -8. The y-intercept is at -8. Let's look at another problem. Example 2. Graph the function, identify the vertex, axis of symmetry, maximum or minimum values, and the y-intercept. We have y equals 3 times x minus 4 times x plus 2. First off, let me label A. A is 3, which tells me that my graph is going to open up and it'll be narrow because 3 is bigger than 1. Step number 2, I need to identify my x-intercepts. So I'm just going to rewrite the problem. Y equals 3 times x minus 4 times x plus 2. Afterwards, I want to set each factor equal to 0. So I have 3 equals 0, x minus 4 equals 0, and x plus 2 equals 0. Now I need to solve each equation. Notice how the 3 does not have a variable, so I can't solve for x. In our second equation, we have x minus 4 equal to 0. To solve for x, I need to add 4 to both sides. So x equals 4, which means that my first x-intercept is at 4, 0. In my third equation, I have x plus 2 equal to 0. To solve for x, I need to subtract 2 to both sides. That's going to give me x equals -2, which means that my second x-intercept is at -2, 0. Okay, class, let's go ahead and plot these points. We have a point at 4, 0 and -2, 0. Now let's locate the middle. The number in the middle between -2 and 4 is 1. That's our axis of symmetry. Which is at x equals 1. To find the vertex, we're going to use the fact that x equals 1, and we're going to plug it into our function. So our vertex needs an x and y value. The x value came from our axis of symmetry. I know that the vertex is going to fall somewhere along my axis of symmetry. I just don't know where. So I'm going to use the fact that x equals 1 and then plug that into my function and find y. We want to rewrite our equation. Y equals 3 times x minus 4 times x plus 2. So that's 3 times 1 minus 4 times 1 plus 2. 1 minus 4 is negative 3. 1 plus 2 is 3. And this is going to give us 3 times negative 3, which is negative 9, and negative 9 times 3 is negative 27. So the y value of my vertex is at negative 27. So now I need to plot my vertex. At 1, negative 27. Since my y-axis isn't labeled, let's go ahead and label it. Let's go by 3. So negative 3, negative 6, negative 9, negative 12, negative 15. Let's make this negative 15. Negative 18, negative 21, negative 24, negative 27, negative 30. Our vertex is at 1, negative 27. There it is. Label it vertex 1, negative 27. Okay, now let's use our a value. A is 3. That's our scale factor. So from the vertex, we want to go 1 unit to the right and 3 units up. Remember, when we labeled our y-axis, we went in increments of 3. So technically, if I were to go 1 unit up, that would represent a 3-unit jump, which is exactly what we want. Okay, so let's go 1 unit to the right and 3 units up, which is just 1 jump because once again, we went by 3s. And if I have a point on my right side, I'm automatically going to have a point on my left side. And that's our graph. Highlight it. Label the parts. We have our vertex, we have our axis of symmetry. The vertex is the lowest point, so we are going to have a minimum. And our minimum y value is at negative 27. And the y-intercept. The y-intercept is where the graph crosses the y-axis. Our y-intercept is at, well, it looks like it's at 24. The y-intercept is at negative 24. And that's how you graph a function that's in factored form.